So, good morning, everyone. As we already know, today we'll have session by Pavan Rao. Pavan is our old student. He graduated in 2011. He was the first autonomous batch student. Thereafter, he has worked in several organizations. I think he got placed in SAP, Alva, Pavan.
Oh, sir.
He got placed in SAP and then he worked in various organizations and now he is with E-Road, New Zealand, where he works on very interesting projects. He has given the list of projects he is working there. So I am hoping for an interesting session from you, Pavan. I'll transfer the host rights to you so that you can start. Okay, now. Okay. Now you are the host. Now you can share.
Okay. Okay, by the way, I've logged in as my wife, so don't
Yeah,
freak out.
yeah, yeah.
Okay, why can't I still see?
You can see one green,
Just a
green.
second.
Yeah.
We'll do 1 second, but yeah. You use Zoom better than me. Can you show me how I share my screen here?
There's a green button at the below menu bar. A green button is
See,
not.
this is really weird. Can you come and share
Sir,
my?
sorry to interrupt. I think you have given the sharing rights to the wrong Pavan.
Oh, is it?
Yes.
No, it is Savita Premakumar Alvena Nindo.
Illa sir, Pavan Rao.
Where is it?
Alla, ನಿಂದು user name Savita Premkumar.
Oh, Savita Prem Kumar. Yeah, Savita Prem Kumar.
I have made you host.
Change it to Pavan.
No. Wait. No. It's okay. That's okay. He has given me sharing rights. How do I share my screen? Oh, share screen. Okay, fine. Got it.
ಒಳ್ಳೆ ಗಾಂವ್ ಕೊಡ್ತಾರಲ್ಲ ನಿಜವಾಗ್ಲು.
ಸರಿ ಏನ್ ಮಾಡೋಣ ಸರ್?
ಬಿಡೋ ಇಲ್ಲ ಆಗುತ್ತೆ.
Yes. Okay. Now you should be able to see my screen.
Yes, we are seeing your screen.
Okay, perfect.
Yes. Now we can.
Small introduction. Sarve Kotputro. So, name is Pavan. I'm a software engineer. I'm not a data scientist. I empower data scientists, let's say. And today I'm going to talk more about data science and telematics. E-Road is a telematics company. So I work for a telematics company. Small brief introduction of what is telematics. You have vehicles driving on the road. These vehicles send information back to us. For example, if you are using Ola or Uber or Uber keeps on sending events back to Ola and Uber. And they can track your movement. Now, apart from tracking your movement, you also have other information with them. You have speed, you have harsh braking if they do. You would know whether they're doing harsh braking. You would also know what's the distance they traveled, so on and so forth. So this is enabled by telematics. And I'm going to explain how data science is used in telematics to bring up some cool stuff. But before that, I'm going to talk about engineering in data science. Engineering in data science, collection of data, how data is collected. Data is collected in many ways. And what are the main challenges and results of data science? I don't want to talk about any specific algorithm that's being used by us because I spoke to our lawyer in our company and he said I'm not supposed to disclose those information. I can only disclose the information that is available in the net. And I also have disclosed some information on Uber, what they have done with the data science output. So if you basically see this multiple parts of data science. One is computer science and IT, which I am heavily involved in. Software development, this is my part. Domain and business knowledge. Here, you don't need maths, you don't need data science. You just need to know the business side of what you want to do or what you want to. You have a lot of data. You want to show something, and what is the business impact of showing that information? The third part is, of course, maths, statistics, and a bit of machine learning. Now, what do I do, or what is engineering in data science? Engineering or data science, I would actually separate it out very entirely on its own. Engineering is collecting of data, ensuring that the data is accessible for using data science algorithms, machine learning algorithms, running machine learning algorithms on your data. Your data is always huge, and ensuring that it's always available. And of course, giving out, writing a glorified UI to make sure that the data that whoever is receiving it, or the end information whoever is receiving it, make usage out of it, make business use out of it, or make governmental use out of it. I'll show that part later. Okay, so in engineering or in real life industries, you get data from multiple places. One is one is from logs, another is from ETL, and another is from actual data pipelines. Brief explanation of all of this before I go into the next part, the challenges. So I don't know how much you would know about writing logs or doing ETL or doing data pipelines. So when an application runs, not an application, you have, in a normal world, in a normal company, you'll have multiple microservices running, and each microservice interacting with other microservices using queues, using streams, using API calls, so on and so forth. So to know what's going on in your system, you log stuff. When I say log, you say log that you received this request, log that you are processing this request, log a specific error, or log to say that this specific thing is completed. You would assume that the logs don't have impact. Logs have impact in terms of the time to access, to maintenance, reliability, and most importantly, for data science as well. So what generally happens with log is log gets written on the system D, and those logs are pushed onto Logstash. Logstash is a data processing application, let's say. I would call it as a tool, but mind however you want to term it as. This Logstash gathers logs from more than one server, not more than one server, all the servers, and pushes it onto Elasticsearch. Your microservices are generally run on multiple VMs, and it's also run on multiple zones. For example, in our case, we have 4 zones running, a couple of them in the United States, a couple of them in Sydney. And you have all the servers pushing the logs onto Logstash, and Logstash gathers them, pushes them onto Elasticsearch. Why Elasticsearch and why not something else? Elasticsearch is the easiest way to store data and easiest way to access data as well, especially when it comes out as blobs. By definition of a blob, I meant a JSON. I don't know if you guys know what JSON is. I'll show you a sample JSON later. And you use Kibana to visualize it. Now, Kibana is just a visualizing tool. Elasticsearch has all the data, which is coming from logs. Kibana, you use it to visualize it. Next thing is you have your standard ETL pipelines. ETL stands for extraction, transformation, and load. You extract data from your databases and you stage it. By staging it, you copy data from place A to place B, and then you push it onto a data warehouse and then transform it to make it look in a decent way. You would use tools like Power BI or what else? You write it on glorified UI for it. I always keep calling it as glorified UI. It's actually really good UI. I'll show some output from data science later, or from the algorithms that run on the data and then giving out a pretty good output. I work on this, we set up this. This is kind of a one-time setup. You don't do much here. You just write new applications or new microservices that keep on publishing logs to the system, and they just keep on pushing stuff out. You don't maintain this ever. You just set it up and then keep it running. You also monitor to see if these are running fine and good, because you get you get data almost every second, not almost every second, actually every millisecond. And you also keep on getting data every millisecond. You need to ensure that it's always running and it can't go down. And to ensure that it doesn't go down, we run this on we run multiple applications of Logstash, multiple applications of Elasticsearch, and keep on replicating data there as well. It's if you start getting into the non-functional requirements, which PMK sir was always emphasizing on, you would know. Once you actually walk into a company, you'll understand the importance of software engineering. You'll also understand the importance of non-functional requirements, which I never understood before I joined the company. Kind of have to apologize to PMK sir. Next thing is, of course, extraction, transformation, loading. They generally don't run every second. They run maybe every day once or every week once, because you have the data already stored in databases. It's just it's just ensuring that you run this when the load is low, so that database doesn't suffer huge load. This is the interesting part. I'm not advertising AWS. We use AWS. That's the reason I went with AWS. Azure, Google Cloud Platform both provide this feature. I have not described our pipeline here. This is not our pipeline. This is just from internet. I was not allowed to describe our pipeline. Essentially, I said that your vehicles keep on sending data to Olas or Ubers, or in our case, eRoad. Keep on sending data to our eRoad. You have a pipeline. The data comes in with minimal set of information: latitude, longitude, vehicle ID, specific UID for vehicle, device ID. For example, Ola and Uber have their own devices in the car, right? They also have device IDs, and maybe some information about the driver, and the speed, and the accelerometer information. Also the odo. Now this set of information is sent across to our world, to our own virtual private environment. In our case, virtual private cloud, VPC. VPC, and we start adding more information along the pipeline. We keep on adding information about the driver, more information about the vehicle, more information about the box. We get the latitude, longitude, and from the latitude, longitude, we try to gather the actual address. And from the address, we try to gather what's the speed limit on those roads, whether the road being driven is a public road or a private road. For example, airport road is a private road. When I say airport road, the roads around the airport is private for airport, and it's also called private road as well. Another example of private roads could be around ports or inside Ramaya College itself, as an example. Those roads are private roads. You would also want to know whether they're driving there or not, and and you also would want to know what's the speed and so on and so forth. Now the speed we use to highlight to the driver that if he's overspeeding, we want to let him know on the device that, hey, you're overspeeding. And if he's going into an area where there's too much traffic to be expected while driving, we kind of let him know that there's too much traffic to be expected, and so on and so forth. Now, that's where big data pipeline works, and I primarily work on this. We write a lot of microservices here. We also use this data to calculate tax. Outside India, generally, you have tax based on the weight of the vehicle that's being driven, and you also have that tax being calculated on the distance being driven. So you need to buy. The road tax is very high in countries in New Zealand, Australia, and in US, because these are main markets. Even in Europe, to an extent, you pay road tax based on the distance that you travel. You buy licenses, road user licenses from distance A to distance B, and generally it's for 10,000 kilometers. And then by the time the license expires, you need to buy the second license, and license, so on and so forth. This is how countries maintain their roads and infrastructure, or improve them. So this is where I work on. I don't do any of this. And this is generally done by very specific people. And I say very specific people who know how to do ETLs, because that's an area which is very niche, let's say. Challenges. Some of the challenges that we face in engineering for data science is the size of data. We experience growth of 300 GB per month and more. 300 GB is actually a low estimate. Today I was seeing it was around 500 GB per last month, and it's continuous. And for you to develop patterns, for you to ensure that your predictions are all good, your data should be for a couple of years at least. Now, if you elaborate 300 GB per month for 2 years, that's huge growth. So 24 into 3, I think it's 72 TB or something, I'm not sure. Or 7.2, not sure. Bad math. That's a big problem. You need to pay for it. You need to maintain it, and it should be reliable, as in it's replicated. If one of your, luckily we use AWS. AWS ensures that our data is replicated and stuff. But imagine if AWS or any cloud was, if no cloud was there, if it was to be done manually, it is painful. But if you use AWS, your cost is going to go high, so you need to do that. Second thing is zero downtime. You basically have no downtime in your real life, in your industrial world. Hearing zero downtime could mean a couple of things. One is you need to keep on releasing new software versions, software products, improving your applications, so on and so forth. But your application should not go down. Your system should not go down. So that's one of the biggest challenges. And then lastly, the engineering time. Again, coming back to software engineering, we focus a lot on non-functional requirements, reliability, stability, performance, and availability, uptime, 99.999, I think 5 nines or 6 nines. Six Sigma stands for 6 9. I think we go for 9 nines or something, to ensure that you're always up. So as an engineer, you always prepare for your worst case scenario and build your application. Even then, things go down. For example, Google went down today. I think today or yesterday, sometime. Google YouTube was down. The reason could be many, but it goes down. Engineering time goes a lot. Engineering time is a lot investing in ensuring that there is no worst case scenario. Results of data science. Some of the results I'm going to show. This is from our company. This is on this side. We were showing the vehicle travel at multiple stages. Actually, this was a GIF. I don't know how to add a GIF to PowerPoint. Better that. But if we had actually seen this, we were able to show the real-time travel at different instances, and we were showing that the collection. So if you see this, there's a huge number of vehicles being collected at this point, and here at this point, and at this point. But at the same time, during lockdown, we had a very strict lockdown here. You see the number of vehicles collection is very low. Because I was not able to get a GIF, I took a screenshot of it. And this is how it looks. If you see this 85% reduction. Now, what's the impact for businesses? What's the impact for the government? That's the thing which data science actually does. It's not just visual representation of this. In this side, this is Uber's data, wherein in Uber, they were trying to map out which are the areas in New York where they have a lot of traffic. When I say a lot of traffic, a lot of Uber vehicles around, and how do I target vehicles to move closer to this so that they get more and more business out of it. So this is where data science comes in. This data, I can guarantee you the volume of the data. This was over a period of 8 years, the volume of data was more than 120 TB. And a lot of analysis goes down here. We aggregate a lot of data. So we get the data, raw data in huge terms, we aggregate, and then show up this data. This one, I'm pretty sure Uber is much more than us. We have just around 150,000 vehicles or something. Uber has much, much, much more in New York itself. And the amount of data that they'd be working on, and the amount of processing that would be going on, and the amount of analysis that would be going on is very high. And the advantage this gives to business, think from a business point of view, you would know that around this time, ask drivers to drive onto these locations so that this is your heat map. This is where a lot of customers are there. Go make money. Go make money for yourself. Go make money for Uber. Some of the impacts that we kind of provide. In Auckland, we reduced the speed limit in CBD from 50 to 30 kilometers. And to do this, we had to prove to the big, big companies with a fleet size of more than 5,000 to 10,000, telling them that, hey, reducing from 50 to 30 kilometers actually do not have any impact on your business. Now, what I mean by that is, for fleet size of that those big companies, the cost for them is when the driver is on the road. And if you reduce it by 20 kilometers per hour, that would mean, for a logical person, it would mean that the cost increases by a huge margin. Every minute that the vehicle is on road is a cost to the company. So we needed to prove it to them that, hey, you know what, reducing it from 50 to 30 actually does not cause any significant loss to you, or significant cost to you, or does not add additional cost to you, because the travel that was going on in CBD around most of the day is around 40 or 35 kilometers per hour. So just the amount of time that you're spending more is 5 kilometers per hour. That would mean a lot of, for let's say 1,000 vehicles, 5 kilometers per hour actually contributes to some cost. So we proved it to them, and then that's what government took. Actually, we had to prove it to the business, as well as we also had to give this information to the government. And government took it up and then reduced from 50 to 30. I don't know if you guys know what is congestion charging. Congestion charging is something where during peak hours, if you travel on these roads, you need to pay additional tax or additional money to the company, to the government. It's similar to toll roads, but there's no toll there. It's just based on your vehicle is there in this location at this point of time. For example, in Newcastle, it's there at this point of time, pay more tax. And how do governments calculate congestion charges? It's based on the heat maps being provided. The bigger challenge, if you look at this, is providing heat maps and providing real-time maps for such a huge scale for the government, for not for some vehicles, for all vehicles. Now that's a big challenge. That's where data science comes in. Data science predicts models for the government and tells them, hey, during this time, during this period, during this month, during these days, your heat map would look like this, and I fix congestion charging. You don't want to be really dynamic with your congestion charging, because if you keep on making it dynamic, businesses would start raising questions and would start revolting. So you don't want to piss off businesses. So you need data science to predict. For example, during Christmas time in London or in UK or in Auckland or most of the places, your congestion charging, your heat map would be a lot lesser, because number of vehicles being traveling around places would be less. But bring it to peak travel time, let's say in February or March or April, where you would want to know, this is what, if you travel in Newcastle, you would have to pay $2 per hour. If you travel somewhere, let's say up north or in Forest Hall, you don't have to pay anything. The cities which have come up with this is Vancouver, London, Singapore. Singapore is a city country, so Singapore. Some places in Europe as well, and Auckland, and I think even entire New Zealand is going to go with congestion charges in about 3 years. And these are the real life impacts. So we tell governments, or data science tell governments on how to do congestion charging, what should be the ideal speed in roads, or what should be the speed of roads. So speed limit in roads based on time as well. So you also see switching of speed limits based on time. From morning 7 a.m. to 9 a.m. your speed limit is 30, and then after 9 a.m. it goes from 30 to 50, and then it goes up to 100 and then comes back down, so on and so forth. These are the real world impacts, and this is what data science does. This is what data science people do. You have one part of it. Engineers who build all the tools, build all the applications to make sure data is available. And we also have the engineers doing the part of visualizing the data. Data scientists build algorithms on R, or they don't build algorithms, they choose good algorithms to run on R, or we can also do it in Java now. Make sure those algorithms are run and create good visualization or good result out of it, which we engineers go and glorify the UI and show it. This is it. I wanted to stop at real world impact. I don't like thank you slides and stuff like that. So that's me.
ಕರೆಕ್ಟ್ ಟೈಮಿಗೆ ಮುಗಿಸಿದೆಯಲ್ಲ ಶಿಷ್ಯ?
ಸಾರಿ ಸರ್,
ಕರೆಕ್ಟ್ ಟೈಮಿಗೆ ಮುಗಿಸಿದ್ಯಾ ಅಂತ. ಅರ್ಧ ಗಂಟೆ ಅಂದ್ರೆ
ಸರ್ ಇದು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ತೀವಿ, ಟೆಕ್ ಲೀಡ್, ಸೊ ಮಾಡ್ಬೇಕಿದ್ದೀನ.
ಆಯ್ತು. ಸೊ ಏನಂದ್ರೆ 9 years ಆದ್ಮೇಲೆ ನೋಡ್ತಾ ಇರೋದಲ್ವಾ ನಾವು?
ನೋ ಸರ್. ಅಂತೂ
ದೊಡ್ಡ ಚೇಂಜ್ ಏನು ಆಗಿಲ್ಲ ಕಣೋ ನೀನು. ದೊಡ್ಡ ಚೇಂಜ್ ಏನು ಆಗಿಲ್ಲ ಅಂತ.
ಥ್ಯಾಂಕ್ಸ್ ಸರ್.
ಪ್ರೆಸೆಂಟೇಷನ್ ಸ್ಟೈಲು ದೊಡ್ಡ ಇಂಪ್ರೂವ್ಮೆಂಟ್ ಏನು ಆಗಿಲ್ಲ ಹೇಳಬೇಕು ಅಂದ್ರೆ.
ಸರ್ ಪ್ರೆಸೆಂಟೇಷನ್ ಏನ್ ಮಾಡೋಣ ಸರ್, ಇಂಜಿನಿಯರ್ಸ್ ಮಾಡಕ್ಕಾಗಲ್ಲ ಪ್ರೆಸೆಂಟೇಷನ್.
ಆಯ್ತು ಓಕೆ. So fine. It was interesting. As you said, most of the details you can't reveal. We do understand that. But whatever you have said, I think students would have got the essence of. But what I was interested in is there, I am very sure there would be a mathematical model which will take all these inputs and then calculate into tax, and doing that, it would have been a very interesting kind of thing to know how it actually happens. ಇವರೆಲ್ಲ ಕಾರ್ಪೊರೇಟ್ಗಳು ಹೇಳಲ್ಲ,
ಏನ್ ಮಾಡೋಣ ಸರ್.
ಅದಕ್ಕೆ ನಾವು ಕ್ಯಾಗಲ್ ಹೋಗ್ಬಿಟ್ಟು ಅದು ಇದು ಡೇಟಾ ಸೆಟ್ ತಗೊಂಡೇ ಅನಾಲಿಸಿಸ್ ಮಾಡಿ ಕಳಿಸ್ಬೇಕು. That's one of the unfortunate thing. Hopefully at least some legacy data, 5 years 6 years data na at least public release ಮಾಡಿ ಕೊಟ್ರೆ at least it will be beneficial for everybody, I think, in the long run.
Okay, I'll take it up with our lawyers.
I think with the Creative Commons license or something, if they are releasing at least some legacy data set with anonymized and privacy preserving concepts put in and all that, so that should be something interesting for researchers and students to work on.
The only problem is privacy, because you collect data of drivers, and they complain. So some people actually put tin foils on those devices, so that when they are not driving when they're using the vehicles for personal use, they put tin foils so that you don't know where they're going or what they're doing. And now we also have instances where we have to turn off processing. So we have now made that as a feature. So privacy concerns in the data and release model kashta agate.
I'm very sure some kind of anonymization can happen with those identity details and other things. And then because why I'm saying this is because New Zealand is a kind of progressive country compared to US with regards to these kind of issues. Maybe it is bit easier for the companies in New Zealand to work around this. US ಕೇಸ್ ಆದ್ರೆ ಸ್ವಲ್ಪ ಕಷ್ಟ, ಅಲ್ಲಿ ಲಿಟಿಗೇಷನ್ ಇನ್ನ ಸೀನ್ ಜಾಸ್ತಿ. ಬಟ್ ನಿಮಗೆ ಸ್ವಲ್ಪ ನ್ಯೂಜಿಲೆಂಡ್ ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಪ್ರೋಗ್ರೆಸಿವ್ ಎನ್ವಿರಾನ್ಮೆಂಟ್ ಇರೋದ್ರಿಂದ ಆಗ್ಬೋದು. ನ್ಯೂಜಿಲೆಂಡ್ ಅಲ್ಲಿ ಏನಂದ್ರೆ ನಮ್ಮಷ್ಟು ವರ್ಷ ಆಗ್ಬಿಟ್ರೆ ಪ್ರೈಮ್ ಮಿನಿಸ್ಟರ್ ಆಗ್ಬಿಡ್ಬೋದು. ಆತರ ಅಲ್ವಾ, ಬೇರೆ ಎಲ್ಲೋ ಆತರ ಯೋಚನೆ ಮಾಡಕ ನಾನು ಅದೇ ಹೇಳ್ತಾ ಇರ್ತೀನಿ. ನಮ್ಮ ವಯಸ್ಸವರೇ ನೋಡು ಪ್ರೈಮ್ ಮಿನಿಸ್ಟರ್ ಆಗ್ಬಿಟ್ಟಿದ್ದಾರೆ ಹಂಗೆ. ಎನಿವೆ, ಯೂಶುವಲಿ ಸ್ಟೂಡೆಂಟ್ಸ್ ಯಾರು ಆಸ್ ಯೂಶುವಲ್ ಕ್ವಶನ್ ಕೇಳಲ್ಲ, ಬಟ್ ಐ ಆಮ್ ಸ್ಟಿಲ್ ಹೋಪಿಂಗ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ವಿಲ್ ಆಸ್ಕ್ ಸಮ್ ಕ್ವಶನ್. ಯಾಕಂದ್ರೆ ನನ್ನ ಪ್ರಕಾರ ಐದರ್ ಎಲ್ಲರೂ ನಿದ್ರೆ ಮಾಡಿರ್ತಾರೆ ಅಥವಾ ಏನೋ ಮಾಡ್ತಾ ಇರ್ತಾರೆ. ಈ ಆನ್ಲೈನ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಬಹಳ ಗೊತ್ತಾಗಲ್ಲ ಏನ್ ಮಾಡ್ತೀವಿ, ಯಾರು ವಿಡಿಯೋ ಬೇರೆ ಆನ್ ಮಾಡಲ್ವಲ್ಲ, ಏನ್ ಮಾಡ್ತಿದಾರೆ.
ಯೂಟ್ಯೂಬ್ ನೋಡ್ತಿರ್ತಾರೆ ಸರ್, ಅಥವಾ ನೆಟ್ಫ್ಲಿಕ್ಸ್ ನೋಡ್ತಿರ್ಬೋದು.
ನೆಟ್ಫ್ಲಿಕ್ಸ್ ಎಲ್ಲ ರಾತ್ರಿನೇ ನೋಡಿರ್ತಾರೆ, ಇವಾಗ ಮಲಗಿರ್ತಾರೆ. Yes, guys, if anybody has questions, you can please put it up in the chat box. All of us can see that. Or if you want to unmute and ask the question, you can ask the question. We'll just wait for a while, Pavan.
1ms 17. Oh, okay.
17 ಅವರು
07 ಇಂದ 17.
10 ವರ್ಷ ಡಿಫರೆನ್ಸ್. 10 ವರ್ಷ, ಅದೇ 9 ವರ್ಷ. ನೆಕ್ಸ್ಟ್ ಇಯರ್ ನಿಮ್ದು 10 ವರ್ಷ ಆಗುತ್ತಲ್ಲ. ನಾನು ಜನಾರ್ದನ್ ಹೇಳ್ತಾ ಇದ್ದೆ, ಒಂದು ಗೆಟ್ ಟುಗೆದರ್ ಮಾಡ್ಬೇಕು ಕಣೋ. 10 ವರ್ಷ ಆಗೋಯ್ತು ಅಟೋನಮಸ್ ಬ್ಯಾಚ್.
ಹ್ಞೂ ಸರ್ ಮಾಡೋಣ.
ವಿಕ್ರಮ್ is with me. Vikram works with me. You know that ಅಲ್ವಾ?
ಹಾ ಗೊತ್ತು, ಹೇಳ್ದ.
He is just there outside.
ಓ ಕಾಲೇಜಲ್ಲಿ ಇದ್ದೀರಾ?
ಅವ್ನು ನನ್ನ ಜೊತೆ ಇದ್ದಾನೆ ಕಾಲೇಜ್. ನಾನು ಕಾಲೇಜಲ್ಲಿ ಇದ್ದೀನಿ.
ಮಾಸ್ಕ್ ಹಾಕೊಂಡಿಲ್ಲ?
ಏಯ್ ನಂದೇ ಕ್ಯಾಬಿನ್ ಕಣೋ, ನಾನೇ ಮಾಸ್ಕ್ ಹಾಕೊಳ್ಳಿ.
ಆದ್ರೂ ಸರ್ ರೂಲ್ಸ್ ಇದೆ ಅಲ್ವಾ?
ಇಲ್ಲ ಒಬ್ಬೊಬ್ಬರೇ ಇರೋದು ಏನ್ ಬೇಕಾಗಿ. So Pavan will formally close the session. And I would like you to come back again maybe sometime next month, because these guys are doing some case studies in data science, and I'm asking few people to evaluate the kind of work they're doing and to give input.
Okay.
That session will take up somewhere in the second half of January.
Okay, sir. Sure.
Okay, then thank you very much, Pavan. We are not giving any money or any token of appreciation. It's just thank you.
No worries, sir.
Okay, then we will connect later. Bye.
Yes, sir. Bye.
Bye.